Welcome, everyone. Good morning, good afternoon, depending on where you are around the world. My name is Nathan Heston, and I'm joined by my colleague, Daniel Moyer. Morning,
Hello,
Daniel.
everyone. Good morning.
Yep, we're out here in sunny California right now. We are far north of the fires, luckily. And we're excited to bring to you a discussion about backup power, which seems rather pertinent. There are always reasons to need backup power. We're going to be talking about programming Sol-Ark inverters that are paired with our Briggs and Stratton batteries. So the majority of this talk is going to be on how to program, and we'll focus on that. But of course, we're happy to take questions and talk a little bit about our generators. Briggs and Stratton is a manufacturer of generators, and we'll be talking about the stackable battery that you can see on the screen there as well, and how to get the Sol-Ark program to operate and run both of those pieces of equipment.
A couple of housekeeping items was this is a NABCEP accredited course, so we will be issuing continuing education credits. At the end of this talk, we will have our email pop up. Go ahead and email us your full name, first and last name, so we get it correct on the certificate, and we'll email it out to you. Additionally, chat has been disabled on this talk, but the Q&A function is available. Please put any questions, comments, suggestions in the Q&A, and we'll be addressing them as we go along.
Great. Thank you, Daniel. So yes, welcome, everyone. We're glad that you're able to join us. Again, NABCEP credits, send us an email at the end. Let us know how you want your name on your certificate, and we will get those generated. So we do want to point out that at the beginning of this, so we just talked about NABCEP. That's my favorite conference to go to. And so if you're interested in learning about renewable energy and getting certification, your NABCEP certification, Daniel and I will be at NABCEP. I'm going to be talking about integrating generators into energy storage systems. Daniel, what will you be presenting on?
Building codes and standards, specifically NFPA 855.
Okay, and that's at the end of March. That's in Reno, Nevada. So if you're going to be there, let us know. We'll have something special for you at our booth. And Daniel, what's coming up even sooner?
Intersolar. Intersolar is going to be down in San Diego, and anybody that's on this call that is looking for a free expo pass, we have them available. You can scan that QR code right there, get a free expo pass, or if you want, email us. Email will pop up at the end, and I'll email you over the link to get a free expo pass. As Nathan said, we'll have a special gift for anybody that visits our booth at either NABCEP or Intersolar.
And by the way, you will be getting a copy of all of these slides, so there's no need to try to screenshot the important ones to you. I'll send out an email after this training is over with a link to the recording in case you need to share that or want to have that for your reference. We'll post it to YouTube. And then I'll also send a slide deck along in that email. So we are excited to be partnering with Sol-Ark. So Briggs and Stratton, SimpliPHI has long been a battery producer. SimpliPHI batteries have been manufactured in California since 2010. And Briggs and Stratton acquired SimpliPHI several years ago now. And we're pairing with Sol-Ark to offer these energy storage packages, which I'll show you on the next screen. Daniel, what a couple of the things that you like about working with Sol-Ark?
Well, Sol-Ark is one of the first companies to come to market with a hybrid, all-in-one Sol-Ark inverter, right? The idea that all the charge controllers are built in, the automatic generator start, the inverter charger, the smart load output, which we'll get into here in a minute, the ability to AC couple. It's really cool to be working with Sol-Ark. They're an American company, just like we are as well. So with American-based tech support, American-based sales, American-based engineering. So we're really here in the States with you. And if you ever have an upcoming project, reach out to us. We may even be able to come out to site with you and help you get that first install done.
Yeah, and Daniel and I really enjoy participating in the installations that are local. I'm local to San Luis Obispo, California, and Daniel's up in Northern California in Arcata. And yeah, we love to participate in these installs and help out. I like the fact that, you know, when you do have American-based tech support, one of the nice things about that is they often understand the local challenges that you have, right? There are differences depending on where you are around the world, such as the grid standard, for instance, and other things like that that our inverters, our batteries have to comply with. So these are the packages that we've released together with Sol-Ark Inverters. We're not going to spend much time on the packages here. Just want you to know that we have packages for each of the different inverters that are there on the screen. There's an indication with the expected amount of backup time. Of course, most people can't back up their entire home with an 8K inverter. But if you're backing up about 50% of the home, we would expect about 11 hours of backup time just from a single one of these stackable 6.6 batteries that we'll be talking about. The 12K inverter, we have a package with 2 of the 6.6 batteries. We would expect that about 75% of the home's loads would be backed up and giving you about 14.5 hours of backup. And then a whole home package where we'll probably spend a little bit more time talking about this today, just because the majority of our installs are done with 15K Sol-Arks. Of course, you can always add more backup time by just paralleling more batteries. You can have a very large battery bank to run with your inverter. There's no problem with paralleling more batteries, having a larger bank. Of course, you get more backup time. One of the things I like about working with Sol-Arks and Briggs and Stratton batteries is that you are scaling the power and the capacity independently of each other, right? So you could have a very large bank, get a lot of backup time, but not have to pay for extra power that the inverter could generate that you don't use. So let's level set here. What is a battery energy storage system? What is a battery ESS? So an energy storage system in the electric world typically is referring to a battery anymore. The majority of energy that's being stored is going to have to be stored in batteries, and most batteries now have moved to LFP chemistry. SimpliPHI's got a lot of expertise in developing LFP technology. And that LFP batteries needs to be paired with an inverter, right? So what we're showing on the screen is our stackable 6.6 battery and an inverter. And that inverter is going to be responsible for managing different power sources, different energy sources. So it could pull power from the grid. It could be pulling power out of the batteries. It could simultaneously be using the battery and the grid. And of course, you can integrate solar into this. You could be integrating AC coupled solar or DC coupled solar. And we'll talk about what we mean by that later on in the talk. But basically, inverters that are either string tied could be brought into the Sol-Ark inverter, or microinverters. That would be examples of AC coupled solar. The more efficient way to do it, and especially if you're doing new construction, would be to just do DC solar, bring that into the inverter. And of course, the inverter is capable of operating the rapid shutdowns that are required for rooftop arrays. The Sol-Ark inverter, this is one of my favorite things about the Sol-Ark inverter, is how easy it is to integrate a generator into the system, right? When the grid goes down, typical generator-based backup systems just start up the generator immediately, right? What would happen if a grid went down and you had a Sol-Ark inverter with SimpliPHI batteries and a generator as backup, Daniel?
Well, one, it would have a quicker transfer time than just a generator alone. That
Yep.
seems like a small point, but you'd be surprised how many people don't want to reset their clocks or wait for the router to reset. So it would start discharging the battery to support the home loads and then start up that generator automatically. One point I want to make, Nathan, here is the idea that battery backup only, no solar, no generator, is becoming more popular. It's something, as somebody who's in the solar industry for a long time, I never really gave it much credence, but there is the opportunity to have just batteries for somebody that doesn't necessarily want solar, can't have a generator because of HOA. Additionally, these energy storage systems, when paired with solar and in a situation where you're not allowed to backfeed the grid anymore, I'm thinking of non-net metering states like California, I believe Illinois just went this direction. We can now store that solar energy in the batteries, not send it back to grid, and then discharge that battery in the evening, at night, so you're not having to rely on the grid as your battery anymore.
Yeah, and I mean, that's a good point. A lot of people don't realize that if they have solar on their roofs, they don't have power necessarily if the grid goes down, right? You need batteries to be able to do that. This is not a talk about wiring, but here is the inside of a Sol-Ark 15K, which you're looking on the left side of the screen are the battery inputs. So you have dual battery inputs. There's a single pole breaker on both of the positive inputs there that's 200 amps. The Sol-Ark is only capable of drawing about 275 amp maximum from the batteries, but you have dual 200 amp breakers there, and that allows you to use smaller cabling. Typically, we'll see these connected with dual sets of 2-aught cable, dual sets of 1-aught cable. And that's a nice feature there. In the center of this picture, you can see the comms board for the Sol-Ark, as well as what's at the bottom of the green and orange there, Daniel?
The MPPT inputs?
Yeah, those are MPPT inputs. We're looking at 3 independent MPPTs. That's our maximum power point tracking devices. That's to bring into your DC coupled solar. And then we have the accessories bar in the center. We'll talk about some of those pins. If you're paralleling multiple inverters, I'm not going to get into how to parallel inverters in this talk in terms of programming. It's a relatively straightforward thing to do, but you would use those paralleling comms there. You only need one cable, and you go from inverter 1 to inverter 2 so that those inverters can share information. The battery CAN bus port there, those are all RJ45 or Ethernet type plugs. The battery CAN bus you will utilize if you're using those Briggs and Stratton stackable communicating batteries or other brands of batteries. The generator port here is shown on the left side of the screen. That's a port that has a 80 amp continuous maximum there, so a little over 19 kilowatts there. And you could use that to bring in a generator. You could use that to bring in AC coupled solar, or you could use that. My favorite method is using that as a smart load output. So you can control the on off of a sub panel based on battery percentage with that. The neutral bar, your grounding bar are there. The ground and neutral should be tied at your first point of service disconnect, which would be right before this inverter. You should have it on a breakered or at least a fused disconnect after your meter. And then you've got your grid input and your load output, and those are rated at 200 amps. So a wiring diagram for a smaller inverter like the 8K or the 12K might look something like this. So you'd be feeding that. Notice we're feeding that out of the main load panel with a 60 amp breaker, Daniel. Would a 200 amp panel allow you to backfeed 60 amps of solar? How can we do that?
Well, one, you could derate the main to limit the amount of incoming current from the grid. You could theoretically have a 225 bus bar that would allow that. Given that you have a 200 amp breaker and a 200 amp bus, with the 120% rule, it'd only be a 40 amp breaker. Now, with some of the PCS controls that are now UL listed, we can now have 60 amps, right? So we want to be able to pull 60 amps from that panel to supply the loads, but we want to be careful not to backfeed more than 40. And we're going to talk about this here in a minute on an upcoming slide, how we can limit that grid cell to not exceed that 40 amps of backfeed. So it's really cool features that are now coming onto the market with this PCS controls.
Yeah, and all of the Sol-Ark inverters are power control. What's the S stand for in that? Power control
Systems, I believe.
Power
And if
control
somebody in
yeah.
you please use the Q&A if Nathan and I got that wrong.
No, I think you're correct. I think it's power control system certified. All of their inverters are, including the 15K. And here we're looking at a 15K. And notice that the wiring is a little simpler here. I'll point out the difference between the loads. So some of your loads with a smaller inverter like a Sol-Ark 8K or 12K, unless you're off grid, are going to be in your main panel, right? And you're only going to be able to back up some essential loads. We'll typically move over the important things, the internet connection, things like your refrigerator, things that you definitely want to have backed up in a grid outage situation. With the Sol-Ark 15K, because of that 200 amps of pass-through, typically people will back up the entire home with this. Now, that doesn't mean you have 200 amps of power output if you're just running off of batteries. If you're running off of batteries in solar, you've got 15 kilowatts of output. If you're running off of batteries only, you're limited to 12 kilowatts of continuous power output. It will surge up to 100 amps. It will surge up to 24 kilowatts. But you're somewhat limited. So people will say, well, that's not truly whole home backup. But if most of your loads are there, I do point out that the average home on a 24-hour, 365-day period over a year, Daniel, what's the average home use?
It's just around 1,200
watts.
1200 watts. Yeah, 1.2 kilowatts
Right.
continuous as well. And what you can also do is some utilities have the ability to pull what's known as green button data, where you can pull 15-minute interval data and really get an idea of what that home might use, not only for energy, but also power.
And it spikes up, right? It'll spike up if you've got a large air conditioner, especially if you don't have that soft start on there. But in most cases, a single Sol-Ark 15K should cover the typical home with whole home backup. Now, I'm going to point out in the next few slides, these are wiring diagrams right out of a Sol-Ark manual. These are out of the Sol-Ark 15K manual. Different uses of the gen port. So what I'm showing right here is so this would be an example where you've got a retrofit. You might have an old inverter on the house. You've already got your permit for that inverter. You don't want to get up on the roof and change things. You might have a micro inverter array on the roof, like an N-phase system up there. Solar Edge and N-phase are the typical AC coupled systems that we see. But we can use that generator port to bring in up to 19 kilowatts of AC coupled solar. And you could refer to Sol-Ark's guidelines about how much AC coupled solar versus use DC solar. It's somewhat independent. The MPPTs are on the DC bus, and the AC coupled solar be coming in on the AC bus. But Sol-Ark gives some guidelines for how much solar you can bring in on the 15K. Now I'm showing a similar wiring diagram, but we're using the generator port here as to bring in a generator. And you can see there's a two-wire signal to start connection that comes out of that the accessories bar on the communications on the Sol-Ark 15K. What that will do is if we have a grid down situation, it will not automatically start up the generator as we're used to with transfer switches, right? What happens if you have a grid down situation is that the batteries will be backing up the home, and the generator doesn't start up until the batteries get low enough that they call for the generator to start up and cover loads and run a charge cycle on the batteries. And that's done with a two-wire signal to start. We'll get into how to program for that and what your options are for that as well. We could also use the grid port to bring in a generator. So you would do this if you're in an off-grid setting. So if you're in an off-grid setting where you don't have a utility connection, Sol-Ark recommends bringing the generator in, a generator if you're going to do one, on the grid port. What does that do, Daniel? Why would we rather have the grid port used for that?
It allows more amps.
Yeah, you get up to 200 amps of continuous power from the grid port that can pass through to your load center, right? That would be a very big generator, right? 24 kilowatts is 100 amps. So it would be 48 kilowatts of continuous power you could bring in from your generator. It also frees up the gen port to use it as a smart load port. Again, my favorite use of that gen port. So if you can put in a transfer switch, and you can bring in that generator on the utility connection side, on the grid side. So just quickly on the wiring, again, we're assuming you've got all the wiring done. You will get a copy of these slides if you have wiring questions. We're still happy to answer them, but if you are wiring in one of our 6.6 stackable batteries into a Sol-Ark, you would wire in through the CAN bus output. You would have your communications come into the Sol-Ark with the included dongle that comes with a 6.6 battery. So we're looking at our stackable battery has a controller that sits on the top, and you only have power. You just have a few connections. You got your power connections coming out of the battery terminals there, and you can double lug those if you want to bring in two cables, one to each of the inputs on a 15K. And then you have the communications connections. Now, we offer an energy track platform. So what you see on the left side of the screen is a Sol-Ark inverter above the battery, but you also see a gateway, and that gateway allows us to do individual battery monitoring. It allows us to monitor the bank on a module level, give detailed information about each of the batteries, temperatures inside the batteries, high cell voltages, low cell voltages, a lot more information that we can pull through the Sol-Ark app. You also get to monitor the batteries through Sol-Ark, though. And Sol-Ark, I will mention later on how you can see some of that information in the Sol-Ark app. So
one thing I want to mention, Nathan, is that, we're talking about our batteries and Sol-Ark. When you do call our tech support is really, truly knowledgeable and can assist on either the Sol-Ark or our energy storage systems. It's not like we're going to say it's not the battery, it's the inverter. Go talk to them. We'll truly be that one-stop shop for your support. Nathan, we did have a question though.
Sure.
James is asking to update an existing solar system with optimizers, replacing the existing inverter with a Sol-Ark hybrid inverter and Briggs and Stratton batteries. Do I need to use microinverters to replace the optimizers? And I'll be happy to maybe jump in on that as well.
Yeah,
There's a couple options.
Go ahead. I will say this.
Yeah.
On AC, one of the advantages of having AC coupled solar, having microinverters on your panels, is that those microinverters are independently optimizing the power output of individual panels. And a power optimizer does something fairly similar. A microinverter immediately converts that DC power out of your panels to AC power, which can then be paralleled at the panel level instead of stringing them together in strings. With the DC optimizers, you're looking at bypassing panels that might be weak due to shading, etc. And Daniel, feel free to jump in there. I know Sol-Ark optimizer is not out yet, but
yeah, and and additionally, both microinverters and optimizers off module level monitoring, so you can tell if a system is a negative maybe on microinverters is that they have inverter clipping. I know you might pair a 400-watt panel in that a micro is not capable of all 400 watts. That's usually acceptable. A lot of times the panel won't output that. Nathan, what's another option besides a microinverter or besides an optimizer that will still allow us to meet the rapid shutdown code?
Yeah, so we can get just specific rapid shutdown devices. So Tigo is a very common one that is used. AP Smart rapid shutdowns can be used. And in fact, you can actually power the AP Smart transmitter, one transmitter, off of the Sol-Ark. I believe it's pins 17 and 18 or 15 and 16. I think you can power your AP Smart transmitter off of them. So yes, you could just do rapid shutdown devices. But if you are looking to truly optimize, there are different optimizers on the market that you could use. And optimizers are typically a significant amount cheaper than the microinverters are. So there are a couple of options there for you. So if you're really worried about shading, you can use those accessories. I don't think I would go straight for inverters, microinverters, because it's a significant extra cost that's not going to provide that much of a benefit.
Nick's asking,
yeah,
are we still planning to integrate our energy track into the top of our batteries, the controller?
I can't I can't say for certain exactly what we're going to do, but my belief is that yes, we're probably going to get the energy track gateway inside the battery controller itself, so you don't have an external device to mount. But I don't have any more information than that. I am showing here, so thank you for these questions. Keep them coming. It makes the webinar interactive. I am showing here, if you are doing multiple batteries together with a Sol-Ark, you would connect those, you daisy chain those batteries in this fashion. So again, you'll get a copy of these slides. The communications that are here allows all of those batteries to work together as a single bank, and you would still need a combiner here to bring this DC power into a combiner if we have 3 or more stackable batteries. Also, we do see, I say the most common problem that we see when we have installers installing communicating batteries is that, they're making their own cables and they might just crimp one wrong. I know my eyesight hasn't gotten any better since I've been in my 40s and have to hold things farther away. And the color code is, it's easy to make a mistake. So if you are making your own cable, we recommend having a tester. These Klein tools are great little testers. You can pick one of these up off of Amazon or at your local Home Depot or Lowe's. They're about $20 to $25. It'll save you hours of headache. So make sure if you're making your own cables that you have a cable tester. So we'll jump into the programming here. Daniel, interrupt at any time with questions, but on the initial setup of the battery, we do have to make sure that the inverter knows to expect a communicating battery. the default on a Sol-Ark inverter is to not have the communicating battery box checked. And because of that, it's not sending the appropriate signals on the CAN bus channel. And so you will see a screen like this on the front of your Sol-Ark. And when we first power that Sol-Ark on, we're going to try to use a different source other than the batteries. If you don't have a different source other than the batteries, we'll just disable communications by unplugging the comms cable from the battery. And I'll explain why here. So when we first start up that Sol-Ark inverter, we're going to want to go into settings, and we could start the inverter for a grid-tied system by turning the grid power on. That's not going to turn power inversion from the batteries on. It's simply going to allow you to program the inverter to get the battery to turn power on from the Sol-Ark. We will have to use the power button on the left side. But if you establish grid power to the inverter by flipping the breaker on, this screen will come up. And we're going to want to go into the settings. That's the gear icon in the top right. We'll go into battery setup. And once you get into battery setup under the BAT tab, there's a box that I've highlighted in red on the bottom right-hand corner. It says BMS lithium battery, and that tells the Sol-Ark, hey, start communicating on the CAN bus channel. And once we've got that box checked, we click OK to save. So remember, when you're programming a Sol-Ark, nothing gets saved unless you click the OK button. So click OK to save that, and then we can power on the batteries. And I'll show you that in the next step. If we have no other power source, like a generator, maybe we've got an off-grid system, we don't have a generator to start up and get the inverter powered up and tell it to communicate on a CAN bus channel, what we can do is we can disconnect the battery cable so that the battery controller it thinks it's running in open loop mode. And then we can power on the inverter off of the battery power. And then we'll go in and we'll check that box for BMS lithium battery in the same way that we would with using grid power. Click OK, and then we'll shut the inverter down. We'll shut the battery down. We'll reconnect the battery communications cables and go ahead and start with the programming. So that's just a note about getting us started. So once the Sol-Ark inverter is programmed to accept CAN bus communication and to deliver CAN bus communication on the CAN bus channel, we're going to need to start with the programming. If the programming has been done successfully and it's communicating with the batteries, you should see the battery capacity immediately show up under battery setup. So for a stack of 3 batteries, it'd be 398 amp hours. It's a 20 kilowatt hour stack that you see in that picture. And then the default for the Sol-Ark, it has some global charge limits that are there. I'll talk about that on the next slide. And then the use battery percentage box will be checked. So the BMS will do some of the programming for you once you've enabled communications. We also want to check that activate battery box in the bottom right corner. What that'll do is if the system runs low and shuts off because of a low battery, if solar comes out, if a DC charging source like solar comes out and is available, it'll allow that inverter to start itself up automatically and start charging those batteries.
I think one of the key takeaways, Nathan, is that the battery should always be the first on and during the startup and the last off if you're shutting the system down as well. Nathan, we do have a couple questions.
Sure.
And please, everyone, keep them coming. Johnny's asking, can a Sol-Ark handle 208? We do have townhomes in San Diego that are 208 and 240. And Johnny, if you're in San Diego, I better see you down at InterSolar. We'll have a gift for you and anybody else that comes.
Yeah, that's a great question, John. They absolutely can. In fact, I'm in my shop right now, and I've got the wall that you can see on the screen there. I've got that in my shop. And my shop is 208. So absolutely, you can do 208. If you want to do 2 legs of 208, like I'm doing in my shop, you can do that off of a single inverter, right? So 120, 208, it's 208 leg to leg instead of 240. The phases are off by 120 instead of 180 for split phase. But yes, you can absolutely do that. And if you want three legs of 208, you can do that with 2 inverters. And if you want balanced 3-phase, you can do that with 3 inverters. I do want to point out you cannot parallel the 8Ks, but you can do 3-phase 208 with the 15 and with the 12K inverters from Sol-Ark. So great question.
Next question from Chris. When you register a new Sol-Ark, it asks for data on other system elements. For the SimpliPHI batteries, it asks for the gateway key. Where do I find that key? I haven't heard that
So
question
that
before.
gateway key is, yeah, it's a good question. The gateway key is actually what you're looking for on the key is you're looking for the communications key on the side of the inverter. So what I think you're talking about is getting the I'm blanking on the name of the dongle, I guess,
Yeah.
the communications dongle on the side of the inverter that's there. So you can see it if I think you can see my mouse. And so this dongle that hangs down there is a Wi-Fi dongle. And so when you first start the commissioning process of the Sol-Ark, you've got to get the Sol-Ark online. And so you can either open up that dongle and plug an Ethernet cable into it, or you can do a Wi-Fi direct. I use my phone normally. I just take my phone and go Wi-Fi direct to, they give you an IP address. It's 10.10.101 or something. Anyway, I don't think I'll get to it here, but they give that right in the manual. We give that in the integration guide that we've put together for you as well. So you can go Wi-Fi direct from your phone to the inverter, and then you set up the Wi-Fi password and in that Wi-Fi direct communication. After that, you can use the Sol-Ark app to communicate settings directly to the inverter. So I believe that what you're looking for there is that key. There's a QR code on that dongle itself. So good question. Yeah, that was something that took me a little while to get the first time that I was doing it as well. So let's start off by talking about charge limits for batteries. So I'm going to specifically point out, with a communicating battery, the battery capacity is going to come in, and the max charge and discharge limits that the battery is capable of will automatically appear. What we are looking at on this screen, though, is user-defined maximum global charge and discharge limits. So what do I mean by that? Well, let's suppose for some reason, maybe the communications on the battery gets disrupted, whether maybe a cable gets unplugged or something happens. It will default to the user-defined parameter. So it's a good idea to go through and manually program the Sol-Ark as well. The other thing to point out is that the Sol-Ark will use the lower of the two numbers. So if I come in here to and set a global charge limit of 100 amps, even though the battery is capable of taking 195 amps, it will use the lower of the two numbers. And so the battery will communicate what it's happy to take, and you can set in here what the max value you'll allow will be. An example of that might be in my shop, I don't have huge cables coming in to charge my inverter. So I want to limit how much overall power I'm drawing, and I don't want to have that charge limit be high like this. 195 amps, at 50 volts, we've got a lot of power, running through cabling, right? So you want to be able to limit that. Now, what do I mean by global? Global means if I have a generator and solar charging my batteries at the same time, maybe the batteries got really low, started up a generator, or maybe grid charging is active, but there's a little bit of solar as well. So global means it adds those two together. One more thing I want to point out, right, is that these charge and discharge limits that we see, 195 amps, Daniel, is that AC or DC?
That's DC. I wish Sol-Ark would add a little DC there.
Yeah, that's DC amperage. So we're talking about DC amperage at, for a 48-volt battery. Typically the charging cycle is happening at about, from about 52 to 56 volts. So that's amps DC. Keep that in mind. Now, if you've got more batteries, if you've got a larger bank of batteries, if we have 4 or more batteries, we're going to have those limits set, or the max value that the battery can take is greater than the value that the Sol-Ark can do. So you can just set the Sol-Ark at the max value. What are the maximum values you can put in there for charge and discharge, Daniel?
275 amps if you have just the single inverter. And that's notable. A single stack of 3 6.6 batteries can handle that 273. It's right there.
Yep. And also to point out that, most batteries, so those are for lower voltage batteries, it'll do a higher amount of power, so it can do more current. But for a 48-volt battery, the maximum current that you're going to see is going to be more like 250 amps, right? Because it's limited to 12 kilowatts of power. So we just talked about global charge limits. Let's switch to the next tab that's on that battery setup. Under the charge tab, this is where I can choose to charge how fast I want to be able to charge my batteries from either a generator that might be connected to the gen port, or micro inverters that could be connected to the gen port. Or charge from the grid. So the left column corresponds to charging from the generator port, not necessarily a generator, but a generator port. And then the right column that you see there is charging sources connected to the utility port or the grid port. So you might have your generator connected to the utility port. In that case, Daniel, how would I program in settings that I want to use with my generator?
You would use the right-hand column there.
The right column for the grid port, right? Exactly. So again, these refer more to the physical location than the device that's being used for the power. So what the settings that you see there, the start setting is, hey, if my battery percentage drops below 40% and there's no utility source, there's no grid source, automatically start up the generator. So it'll send a 2-wire signal to start a generator if you have one, right? And then it will limit the amount of charging that it does from that generator port to 60 amps DC, right? Now, remember, if you are running a smaller generator and that generator comes on, when a charge cycle is enabled on the batteries and you might not have enough solar to cover your loads, the generator has to cover the loads and the charging of the batteries. So you might want to limit how much charging you do so you don't overtax your generator, stall it out, or just overdo it. On the grid side of things, the same thing. I mean, you have the ability to limit how much charging you're pulling from the utility. And here we show it, limited to 100 amps. These are variable settings. You can set them to what makes sense for you. If you have a generator connected to the grid port, and there's a checkbox that you can check. I'll show that later. If you have a generator connected to the gen port, then the right column percentage there is what triggers the 2-wire start. So this percentage is the 2-wire start signal when you have a generator connected to the gen port. This
grid port.
To the grid port, thank you. And then the one on the left, the 40% is when you have a generator connected to the gen port. So
another thing you might notice here is that the generator exercise function, Briggs and Stratton generators can automatically exercise themselves and also do the burn off cycle. You can disable the generator exercise in the Sol-Ark by simply adjusting that time to 0. And
yeah,
that
so
will
if you
then
put
allow
all zeros in the time for the hours and the minutes here, then that will disable the 2-wire signal to start from occurring. You can also force the generator to start up by checking the Gen Force box and clicking OK. You can turn it off by unchecking and clicking OK again. Now, also note that we have the same values for float, absorb, and equalization here. With communicating batteries, the battery is going to control those settings, and it does it by setting just one common voltage that it wants to see from the charge controller. So these are smart batteries. They're going to control that automatically. Generally speaking, we would float our batteries at 54 volts. We would absorb up to 56 volts. And then we don't use an equalize function with LFP batteries. That's a lead acid battery thing. Equalize is there to have a high voltage to burn that sulfur off of the lead acid plates. On the battery discharge side, so the next tab, on battery discharge, what values you see on the screen? You see a shutdown, a low battery, and a restart. Now I note here that you can see that volts are grayed out there. That's because the battery we selected to use, or the battery selected to use, battery percentage, right? So if you have the battery percentage box checked, you would always see that battery voltage grayed out, and vice versa, right? So if you had a different battery that was non-communicating, ours automatically sets percentage. But if you had a different battery, you might see the percentages grayed out and the volts as your settable values there.
The shutdown percent is when the inverter will stop supporting loads.
Yep, from battery. Yep.
the low battery, which should be higher than shutdown, that's when you're going to get an alarm indicating that you're near a low battery cutout point. And then the restart is the point at which, if it does go to a shutdown, it's not necessarily going to turn back on right away. You want the batteries to be able to be recharged up to maybe 50% and then allow the inverter to then come back on when it knows it has some reserve there as well. And then
Yeah, and
battery
these are settable values. So I would just point out to people that, you know, because we're showing 10%, 20%, and 50%, that doesn't mean we're recommending those. In fact, on the battery empty voltage, I recommend a 48 volts here. So Daniel, thank you for pointing out what those mean. So yes, as Daniel was saying, if the system is running off of battery because grid's down or you don't have grid, and the battery starts to get lower and lower, once you hit 20%, it's going to give you an alarm. It's going to start beeping at you. If you don't have beep disabled, it's going to say beep, beep. And that just means batteries are getting low. When you hit the 10% setting here, it's going to shut the loads off. So you're going to lose power. And then if there's available solar and those batteries are climbing back up, once you hit the restart percentage, now if it was me, I'd probably set this closer to 30%, it will turn the loads back on. So the restart is the value. If those batteries are being charged from solar, that'll start supporting loads again. It'll automatically do that without you having to interrupt or intervene. Battery resistance. This is the resistance of the entire bank. For our batteries, it should be 24 milliohms divided by the number of batteries you have, because they're paralleling these batteries. The resistance goes down the more batteries you have. The battery charge efficiency, we'll set that right at 99%. These are very efficient batteries. It does vary a little bit, but that value is really only used by the Sol-Ark to adjust the shutdown voltage. And since our batteries are operating on a state of charge, a percentage mode, we don't actually end up using that to adjust shutdown voltage. But if you are using one of our batteries in open loop mode, this battery efficiency here can help regulate what that shutdown voltage will be. If batteries are communicating properly, if you've got everything set up properly, you'll see a lithium battery info screen here. And if you check that, you'll see information like is appearing on the right side of the screen over here about the batteries, information on the batteries. So that extra menu appears in setup when you have communicating batteries. Also, it's worth noting that our batteries will request 65 amps. That's the value one battery can take until a charge cycle begins, and then that value will increase up to the global maximum that you set. Okay, let's talk about different ways to use the Sol-Ark. Just want to do a quick questions check. Daniel, do we have any unanswered questions?
Not currently, and keep them coming if anybody has one. And,
okay,
and maybe let us know if anybody's used the Sol-Ark smart load output and how the homeowner liked it.
Yeah, so this is, like I said, one of my favorite ways of using the generator port as a load output. So what you can do is you can wire in a sub panel out of the generator port. You could have up to 80 amps continuous power if you're using pass-through from the grid. And what you can do is you can have that panel shut down when the battery percentage gets low. So a good example of when this would be useful is, remember, your solar system is only kicking out power when it has somewhere for that energy to go. And so if your batteries are charging up, that's probably the first thing you want to happen. You want to charge those batteries up during the day when solar is available. But if your batteries charge up, I was looking at one of our customers' sites earlier this morning. He's got a lot of solar, and his site charges up. Those batteries charge up by 11 a.m. So, you know, it'd be useful to have a place for that extra energy to go. So you could put in those things like hot water heater, you know, places where you can dump that energy in a grid down situation. You can put that solar energy there, but you don't necessarily want to be putting that energy there if your batteries are empty. So what we can do is we can always have that sub panel on if the grid is there, but there might be some loads you just don't want to back up in a grid outage, right? And that might be things like a car charger. Don't necessarily want to be draining your home battery so you can charge your car up, right? You might want to put that water heater on there. If you have an electric water heater, you might want to have an air conditioner on here, right? Maybe have small window units on the main load center, but have that big whole home air conditioner on a load shed panel. And so if the grid is up, if you have that box for on grid always on checked, then that sub panel would always be on if grid utility power is available. If you have the use generator input as a load output, that's where you would have that power to the sub panel on based on battery percentage. So notice in the bottom left corner of that menu there, you see an 80% and a 90%. So when the batteries get below 80%, it's going to kill that. It's going to kill that sub panel, right? It's going to turn off those loads because those are not important loads for you in a grid outage event. And then it'll allow those batteries to charge back up, hopefully off of solar or another means, right, off of the generator, if you have it on the utility port, until it gets above 90%. And I misspoke there. Even if you have a generator on the utility port, that sub panel would always be on when that generator comes on. So
one thing I really like about this, Nathan, and kind of going back to the off-grid talk. So when a house is not receiving utility, this is essentially an off-grid house, and a lot of living off-grid requires behavioral changes, so that you have to tell the homeowner once the batteries are charged by noon and the sun's still producing energy on your solar panels, the batteries are full, loads are saturated, go ahead and start using up that extra power, because otherwise, as you mentioned, it has nowhere to go. With the smart load output, it takes that necessary action out of the homeowners.
Yeah, you don't have to say, okay, now go over and start up your water heater, right? You can, it simply will do it for you based on the programming here. Daniel, what's the reason for the discrepancy between the 80 and 90% there?
Well, you don't want it necessarily flickering on and off.
Yes.
So you want to give a little buffer there so that it can charge up and then have that ability to come off. If it was right at the same, you might have it kind of shutting on and off rapidly.
Frequently, exactly. Yeah, and that's what we can see in the bottom right corner here. I've just noted why that happens in a bullet point. What else could we use the gen port for? Well, we mentioned earlier AC coupled solar. We showed this diagram earlier. You know, the recommendation is if you're doing AC coupled solar to bring it in through the gen port. You could bring it in on the load side, but if you do that, the gen port is no longer available for use. So bring it in on the gen side. It does take a little bit of extra wiring, but if you bring it in there, you'll get to see the micro inverters in the Sol-Ark software. So when you're doing your monitoring, you get a little bit more information if you bring it in through the grid port or the gen port.
Gen port, yeah.
Okay, for settings here, so in that same smart load tab, again, this is the smart load, just refers to the generator port. We'll check the box for AC coupled solar input to the generator. High frequency here, it's going to shut those microinverters off by going above 62 hertz. That's the standard here in North America. So that's the 1741 SB. And then on grid, always on. So as long as the grid is up, you can have that box checked, and then those microinverters could always just send excess power back to the utility there. Now, notice that the off value has switched. Notice that the off value for batteries is when you go above 90%, it turns off the AC coupled solar. And then when you drop down below 80%, it'll turn it back on. Why do we want to turn off the AC coupled solar in a grid down situation, Daniel, when the batteries are above 90%?
We want to be able to shut the AC coupled solar off before the batteries are full. It's not necessarily an instantaneous thing, and if we get it too close, there's a chance you could damage the batteries by not turning off that AC coupled solar. It's not like a charge controller.
Yeah, and remember that, you know, micro inverters are trying to kick out as much power as they can off the solar panels. So they're really trying to produce full power and push that somewhere. And if there's nowhere for that energy to go, we need to be able to push that energy into the batteries. If the batteries are full, there's nowhere for those microinverters to go if the grid is down. And so that would shut the microinverters off and prevent overcharging the batteries. And that extra 10% that we're leaving there, if you have a really big battery bank, you could bring that number up to 95%. But that's just a little bit of a buffer so we don't damage the batteries. Keep in mind, if you do have AC coupled solar coming in on the gen port, you do have to have grid cell enabled. So you'll need to make sure that you have that interconnection agreement generally people that have AC coupled solar on their roofs typically already have that interconnection agreement in place. If we have a generator coming in on the gen port, we talked about this a little bit earlier. You can use the two-wire signal to start. That two-wire signal to start will start up the generator in a grid down situation based on battery percentage. So let's suppose you have a generator and you have your battery bank and the grid goes down. Well, your loads in the house are going to run off of those batteries until those batteries get low enough that it calls for the generator to start up. So there's some nice things about this. You save fuel, you reduce run time on the generator is going to last longer, less maintenance on the generator. And so you would use pins 7 and 8 to automatically start up the generator. That's a dry contact, and those are normally open pins. What do we mean by that, Daniel? What's a dry contact?
That it's going to simply close when it calls for the generator to start.
Yeah, essentially pins 7 and 8 would be connected to each other by a relay inside the Sol-Ark, right? And so if you have, you need to have that source of voltage coming from outside. So a dry contactor doesn't provide any voltage or current, it just closes those pins. And so with a Briggs and Stratton generator, if you're using one of them, then it would be pins 4 and 5 for our controllers. I'm showing the 26K power protect on the left and a 13K on the right. And those are pins 4 and 5 are the two-wire start. That's a normally open contactor, and when it's calling for two-wire signal to start on the Sol-Ark, it closes, and that will start up the generator.
Now, Nathan, I know we only have about 9 minutes left, but one thing you are going to have to do with our generators is that the generators, ours at least, are constantly receiving voltage and current from the grid. That's to keep the starting battery inside the generator charged, keep any cold weather kits on in the battery. Additionally, the generator is looking at that grid sense to determine whether or not it should start itself up or shut itself off. What you're going to do in the Sol-Ark situation,
they come from the factory program this way, right? So
yeah, yep. And so if it's receiving power like it would if you had a Sol-Ark there, even in a grid down situation, it's not going to start. You need to go in there and change the configuration so that mains monitoring, if it does still see the presence of grid, it still will start up if it sees the two-wire signal to start.
Yep. So we'll disable that. We're going to disable mains monitoring, and we're going to set it up for two-wire signal to start by doing that. In the interest of time, I'm going to run pretty quickly. We talked a little bit earlier about what these values in the gen charge column mean. So if you have a generator connected to the gen port, that 60 amps is 60 amps DC charging that will occur on your 48-volt battery bank coming from that gen port. Now, keep in mind, if a generator is there, your generator also has to cover loads in a grid down situation while it's charging the battery. If you have a smaller generator, or if you're concerned about that, you can go into the Basic Setup Advanced tab and set a gen limit power, right? So what you see on the screen in the bottom right-hand corner is we've programmed in 13,000 watts there. So we limit the amount of power that we will pull from the gen port to that. And if you go over that amount of power because your loads get high and you are charging too fast, it should reduce your charge rate to not exceed that 13,000 watts you've programmed in there. So it's a helpful feature. Another reason I like Sol-Ark is having all of these settings available.
Absolutely.
Now, Daniel, this one came up in a Facebook chat group that I'm part of. What's that line mean there on the left side of the screen?
That is the two-wire signal to start has been engaged. And again, another great thing about Sol-Ark is that little power line changed to the picture of a generator.
Yeah, so it tells you when that grid icon gets yellow, it means, hey, the grid is down, or I don't like the signal coming from the grid, so I've disqualified it. I'm starting up the generator. On the right, once that generator has been qualified and the signal, the sine wave is good, it starts using that power. You'll see those green arrows flowing from the generator down into the device, right, into the Sol-Ark. So it's pulling power out of the generator, coming down in, and then you can see those arrows going up to the battery. When you have negative power on your battery side there, it means that the battery's charging. It means it's sending power out to the battery from the Sol-Ark. So The perspective is from the Sol-Ark inverter. So when you see lines coming in, that's power coming in. When you see lines going out, that's power going out. Thank you. All right, so let's go to the grid port. And Daniel, keep an eye on questions in case we've got them, but let's go to putting a generator in on the grid port. So we talked about this earlier. I've shown this screen already. By using a transfer switch, we can now get up to 200 amps of continuous power from a generator. So if you had a larger generator like our 26K Briggs and Stratton, you might want to use a transfer switch so you can access all of that power that you've got from a bigger generator. And so in this case, we talked about programming already. In this case that we've got the generator connected to the grid port, you still get the 2-wire start functionality there. It's just going to be based on a different column. Also, if you have the generator on the grid port, you can still utilize AC coupled solar. Now, you wouldn't want that solar powering and trying to backfeed the generator, right? So what can we do about that, Daniel?
One thing we can use is one of our SimpliPHI 2 load management modules and set it for lockout. You know, and one of the John Cromer has addressed this. Even without the AC coupled solar, we might have DC coupled solar on there, and we could start backfeeding the grid. I think another testament to how well Sol-Ark can integrate with the generator is the Sol-Ark will recognize that if it sends back to the grid and it happens to be a generator, it will see the frequency, the voltage start to fluctuate more than it should had it not been the grid, and will curtail that backfeeding of the generator.
Right. We don't want to burn out the generator. So there are some things that we need to do if we've connected the generator to the utility port. Under the grid parameters settings, other tab, there is a box there that you should check. It says Gen Connect to the grid input. The zero export power there is kind of the tolerance, I believe, and then that battery first box should always be checked. I don't know of occasions. I've never had an occasion in which they've told us to check the load first box, and I think they even plan to disable that feature. So that just tells the inverter where that solar power should be going first, and in almost every case, it's the batteries. Also, we mentioned before about disabling auto main sensing. We're including those instructions here again if you've got a Briggs and Stratton generator. Under the battery charging, now we're going to program the settings where we want the charge cycle to start on the column on the right. And we need to have the grid charge box checked because that's where the power is coming from. So before, when I mentioned that those two columns, it's not really the device, but it's the location, it's the port where that power is coming from. And so in this case, if there's a grid down situation and the batteries get below 50%, it will send a 2-wire signal to start. The generator will start up and it will pull power into the inverter through the grid port once that transfer switch kicks over.
And it will charge the batteries to a full cycle to 95% or so.
Yep.
We don't have time in this talk, but there is ability to use the time of use settings to adjust that ability to charge the generator, using generator to charge the batteries to different stated charges.
Yeah, and I will be covering that in NABCEP, and I am sure we have a generator integrations talk coming up fairly soon as well, Daniel. I think I'm doing one maybe next month. There's a talk that Daniel had originally put together. There's a lot of great information about it there. You also have the ability, Daniel just mentioned, using the limiter, right? You have the ability to control the flow of power into and out of the batteries using a time of use setting. So under the limiter, let's talk about the different things that are here. So that grid cell box here, that limits how much solar power can be sold back to the utility by powering backfeeding through the grid, right? So if you set that box to 6,000 watts, as is shown on the green screen, that will just limit how much power will come out of the inverter and go to utility. Limited power to home, what is that, Daniel?
That's so that we don't, we keep everything limited to the home and we're not going to be backfeeding.
Yep. And then limited power to load. So this is more common with the 8K and the 12K. when you don't have all of your load connected through the inverter, you could limit power to the home, you could limit power to the load. And so what that does is it uses the CTs to measure how much power is being pulled from the grid, and it exports the difference between the amount of power pulled from the grid and the amount of power it's sending to the loads panel. And it'll backfeed that to your load center, but not necessarily send any back to the grid. So you can use that limited power to home for that. Limited power to the load will limit how much overall power you're using from utility to go to your load by supplementing that with battery or solar power, right? So solar power will always be used to try to cover your loads. You can supplement battery power to cover your loads, so you're never pulling more than a certain amount from utility. And that can be very useful for things like peak shaving, right? Limiting power to home, you could shave off peaks from the utility if you're getting charges by going over a certain power threshold. And then, of course, we have the time of use settings. And you can set these to be seasonal as well. You can do days of the week, and you can have season settings as well. So a lot of times people will do like a winter and a summer season because you get a lot less sun during the winter. And so your settings might want to change. And the settings that you're giving here, the charge setting is when you're buying power. So you can limit how much power you buy from the grid to a certain time window, and that's used to charge the battery. So you're not trying to charge the battery too fast during, a period of time when the electricity is expensive, for example. You can also sell battery power back to the grid during times when, so Daniel and I are in a place where, there are times when they pay a decent amount of money, right? I'm thinking September, right? Those times when the utility actually pay us a couple dollars per kilowatt hour to offset the demand that they need to supply.
Now, Nathan, we are at the top of the hour. I have a couple questions. I'm going to save them to the end, and we'll get here everybody their NABCEP credits here in a second.
Great. So I'm going to just jump to the end here. We certainly have more slides, but we want to take some time to answer questions. I'm willing to stay a few minutes extra if people want to continue. We realize we're out of time here. So let me jump to the end. For those of you who have NABCEP credits that you need to get, we have our email up on the screen. EnergyStorageTraining@basco.com. So it stands for Briggs and Stratton Company.com. EnergyStorageTraining@basco.com. Send us an email. Tell us how your NABCEP certificate should appear, what your name should say, right? How your name is spelled. And
we do have a couple of promotions, $1,000 off. Anybody who does their first install, we'll give you $1,000. And after that first install, you'll be qualified to join our IQ installer program. That will give you $100 off every battery going forward. We've extended it through 2025. So cool promotions available. Scan the QR code or email us and we'll get you inside that program as well.
And again, you will get these slides that have that link if you're interested in signing up. Daniel, are there any questions in the Q&A for us?
Yeah, so Chris mentions, it's more of a comment. Please note that Tigo rapid shutdown devices system will keep the panels off after a low battery shutdown. So you can't depend on the array to recharge the battery. Without a generator, you have to overcome the Tigo by providing it with an alternative power source. For example,
this is
portable
a
power supply.
Problem that I've run into, yes.
Then the Tigos will allow the panels to produce. Go ahead.
So you could use something like, I have a UPS right next to me here. So unfortunately, that is correct. That the Tigo transmitters will use power in order to keep the solar alive. So it's one of those unfortunate consequences of the rapid shutdown rule, right? Is that your solar sometimes will not start back up after a shutdown event. So there are different things you can do. For one, you could power the rapid shutdown transmitter of the Tigo directly from the DC power of the batteries. And so that's what I've recommended to installers is to get a 48 volt to, I believe some of the Tigo transmitters will take 24 volts. So you could get a power supply that'll pull DC to DC. Or you could get you could get a battery backup for your Tigo transmitter, which seems ridiculous. But yes, that is an unfortunate consequence of using the Tigo rapid shutdown devices. If you use the AP Smart ones, they power directly off of the inverter comms bar, and those will work. So it's another reason I recommend the AP Smart ones.
And the reason we can't put the Tigo on that is they draw a little bit more than what the Sol-Ark
Too
pins
much
can
current.
provide.
Yeah, it'll only allow you to do 100 milliamps of current off that bar, out of those pins, and the Tigos pull more than that. So you get 12 volts, 100 milliamps, so not a whole lot of power, a little over a watt.
Timothy's asking, can AC coupled PV go to a sub panel with loads that's connected to either the load or the gen port?
Yes, absolutely, they can. And typically, so I said earlier in the talk, it's a little bit of extra work to reroute your AC coupled solar. Yes, so people will just leave the AC coupled solar in the load center, and then you have to have that box checked for AC coupled solar on the load side, which is fine. You can do that, but then the gen port is automatically disabled on a Sol-Ark if you do that.
And the telemetry, right? You're not necessarily going to know the output of the PV unless you go to the PV app, because the loads in the load center might consume some of the energy being produced by the PV before it has a chance to go back up into the Sol-Ark.
Absolutely. So I don't have a great screen of that here. But if you do have the micro inverters come in on the gen port, what you will see is there's a little micro inverter symbol that will appear here, and you'll be able to independently track your AC coupled solar from all your other sources of power. If you mix it in by having, by putting it in on the utility load side or the utility side, you lose the monitoring ability. So that's one of the reasons I recommend doing a little bit of extra work. Normally it's 20 or 40 amps maximum to bring it in on the gen side. Yeah, great question. Are there any more, Daniel?
Yeah, one more. Mike's asking, is that promo available for Canada? And I believe it is.
It is. Yes, it is available for Canada now as well. And those battery rebates, that $100 per battery installed for installers that are, doing 100 batteries a year, that's $10,000. That adds up. So we highly encourage you to make use of that, and get those rebates that are offered.
Thank you, Nathan. That's all the questions we had.
Hey, thank you, everyone. We greatly appreciate you joining this webinar. We'll see you next time. Again, energy storage training at basco.com if you have questions for us. So until next time, thank you.
Thank you, everyone.